Hi, welcome to another video. Today we'll be solving the question of sorting a linked list using merge sort. So let's have a look at the example. And here we are given this linked list starting at node 4 and going all the way to node 6. And we have to sort this linked list using merge sort. So previously we covered the question of merging k sorted lists. So for merge sort, most of the people just memorize it. So to understand merge sort better, I recommend it to study it for arrays and linked lists together so that you understand the difference between arrays and linked lists. And previously, in our question of merging k sorted linked lists, there we were given an array of linked lists of k size, and we were able to leverage array indexes to write the divide and conquer algorithm. Here we are only given this one linked list, and we have to design our algorithm for divide and conquer, and by simply using pointer traversals. And since linked list does not have indexes, so we'll have to use pointer traversals, and we are going to have to break the linked list into subproblems and then apply divide and conquer to sort this linked list. So if we think from our previous question of merging k sorted lists, so here we can simply divide this linked list of size 6 into 6 nodes, and this will give us an array of 6 nodes, and then we can simply use the same algorithm that we used in our previous problem, and that would help us to sort this given linked list. But this approach will use some extra space, and we don't want to use extra space to solve this question. Let's have a look at this diagram and design our algorithm for merge sort. So here I am given this linked list with the head pointing at node 4, and we have to use constant space. So the first thing that comes to my mind is what is going to be the smallest subproblem. So the smallest subproblem is going to be just say one node. So here this node 4 is going to be one subproblem. This node 2 is going to be another subproblem, and then node 3, node 1, node 5, and node 6. And then we have to merge these subproblems and form bigger subproblems. So initially, when we merge these nodes 4 and 2, we are going to get a bigger subproblem of size 2. So our subproblems are already sorted. So initially when we have single node, so it's already sorted. And after we merge these single nodes, we get a subproblem of size 2, and it is sorted. So to merge two subproblems, we can simply use merge two sorted linked lists algorithm. And previously where we covered the question of merging two sorted linked lists, so we can simply use that code. And so let's draw another diagram and understand this better. So let me draw a dummy node first. And then node 4, then I have node 2, then 3, node 1, node 5, and node 6. So this algorithm is going to involve changing the pointers and updating the previous and next pointers. So that is why I have used this dummy node here. So my -1 can call this dummy, and my node 4 is initially the head. So what I can do is to divide the linked list into subproblems. So initially my subproblem size is just 1. So I'm going to use k to denote the subproblem size and assign it equal to 1. So initially I can only start from the head node. So let me call this node 4 as current. So now I have to divide this linked list into pairs, and each pair has nodes of size 1, And let me call the first part in a pair as left and second part in a pair as right. So this left, it denotes the head of the first part, and right is the head of the second part. So these two parts, they are currently of length equal to 1. So what I need to do is I need to find the end of my left part first. So we know already that my left part is of length 1. So what I can do is I can find the kth node starting at current. So my kth node starting at current, it's going to be current. So my left part will only have my node 4. And let me call this as end 1. And now here I have to break my linked list. So what I have to do is I need to set 4.next as null. And before I set 4.next as null, I need to save it. So let me save it in right. So this right denotes the beginning of the second part of the whole pair. So this right node can be null. So we need to check if right is not equal to null. So if right is not equal to null, then we call this find kth node for this right node again. So this find kth node is going to have the reference, the linked list reference first. So we'll have right, and I can pass in the k value, and then I find the kth node again, which is the end of this part. So the end of this part is going to be right node itself because it's only is going to have one node. So my end 2 is going to be node 2, and again I modify this, and before modifying I need to save it. So let me call this next, and then I modify it and point it to null. So now I have my left and right parts. So after I get my left and right parts, I can simply merge them. So I'm going to call merge two sorted lists, and I can pass left and right. So after I merge them, I'm going to get a linked list starting at node 4, now node 2, and then ending at node 4. So this will have two nodes now. So this forms a bigger subproblem of size 2. And now we have to connect this merged part with my original linked list. So to connect that, so this is going to look something like this. 2 and 4, and then 3, 1, 5, 6. Then I have 3, 1, 5, and 6. And so initially this was previous. So my merge two sorted list function is going to return the head of the sorted overall linked list. So let me call this merged. So to join these sorted nodes in my original linked list, what I did is I set my previous dot next equal to merged, and I already had saved my node 3 in my next reference. So to join the end with the next, what I need to do is I need to traverse till the end of my merged linked list till node 4 here, and I can simply iterate my previous pointer, and my previous will become node 4. And then what I can do is I can set my previous dot next equal to next, and I'll have to iterate over the merged part. till previous dot next is not equal to null. So it would look something like this. While previous dot next is not equal to null, I'm going to move my previous equal to previous dot next, and I do this previous dot next equal to merged before doing this step, because for the next pair my previous is going to be at node 4 and my next pair is going to be nodes 3 and 1. That is why we have to move the previous pointer till the end of the first pair. So that is why we moved our previous here. And for my next pair, the current is going to become equal to next. And now I can move on to the next pair. So after sorting the next pair, what we are going to get is we're going to get -1, 2, 4, 1, and 3, and so on. And then I'll have 5 and 6, which is already sorted. So this will be the linked list after we sort nodes of size 1. And now our subproblems are going to be of size 2. So as you can see, these subproblems of size 2, these are already sorted. And now we are going to have to start again from the beginning. So we have our dummy node here. Dummy. And I'll set my previous again to dummy, and my current would be equal to dummy.next. And now my k will become equal to k into 2. So now k becomes equal to 2. And after I am done sorting these pairs, what I'm going to have is something like this: -1, and then I'm going to have 1, then 2, then 3, and 4, and then 5 and 6 will remain as it is, because for this pair 5 and 6, my left will be at 5, and now my right is going to be null. So now when I call merge to sorted linked list for left and right, it's simply going to return this pair, and this would be 5 and 6. So now my k is going to be equal to 4. So my first subproblem would be this, and my second one is going to be this. So as you can see that my second subproblem is only of size 2 and first subproblem is of size 4. So here it could happen that it's just simply less than 4 if we don't have enough nodes at the end of the linked list. So that's fine. And we simply merge this. So this would become left and this would become right. And after we merge this, then this would give us the sorted linked list. So I hope this made sense, and this would make even more sense when we start writing the code for this algorithm. So let's jump into the code implementation for this problem, and we'll also try to optimize our code implementation to make it cleaner. So let's have a look at the code implementation now. So here we have to implement this function sort list. So for our merge sort algorithm, we are going to use iterative version of merge sort, because for linked list problems, it's easier to code the iterative approach rather than using the recursive one. So let's write the algorithm for this. So initially, what we are going to need is we are going to need to find the length of the linked list. So we need to find the length of the linked list because we want to put a bound for our k, and we don't want the k to go beyond length. So we want to check that k should be less than length. So for finding the length, I'm going to use list node current and set it to head, and then I can use while current is not equal to null, can simply increment length, and my current is going to be current dot next. So now I have the length. So now I can define my dummy node. So it's going to be list node -1, and my dummy dot next is going to be head. And next I have to define k. So I can define k in my for loop. So I can have k equal to 1, and k should be less than length, and we have to double k. So k will be do k into 2, and in our inner loop we are going to solve for subproblems of size k, where we have pairs of subproblems of size k, and for that we have to define previous first. So previous would be equal to dummy, and can define current equal to previous dot next, and at the end I have to return dummy dot next. And now in my inner while loop should be simply current should not be equal to null. So when current becomes equal to null, then we have traversed the whole linked list, and then we can move on to multiplying our k by 2. So before writing our inner loop, we need to write the function for merging two sorted linked lists. So for that, we write merge two sorted lists. So here I can have list node L1, list node L2, and again can have dummy new list node. So you can have a look at my previous video where I covered merging two sorted linked lists. So dummy dot next after return at the end, and now I have to do list node can simply increment L1 and L2 rather without using two additional variables. So what I have to do is while L1 is not equal to null and L2 is not equal to null, and I need a current variable as well, be equal to dummy. So if L1.val is less than L2.val, my current dot next will be equal to L1. L1 will be equal to L1 dot next, and else my current dot next will be equal to L2, and L2 will be equal to L2 dot next. And then I can increment my current equal to current dot next, and then we'll have the case when either one of them is null or both of them are null. So if L1 is null, then I can simply set it to L1, else I can set it to L2, and I can return dummy dot next at the end. Yes. So let me double check this. So I have my current, and then I move my current equal. Yeah, that looks good. So now let's think about our inner while loop. So initially we need to divide uh like we need to divide our pair into two different parts, left and right. So I can write left as current. So this will be starting off my left part, and somewhere I need to have my right. So after I assign my left variable, what I need to do is I need to find the end. So I can define end1, and then I can do find kth node. Then I pass in left and k. So let's write our find kth node function. So here we are going to have list node find kth node, list node int k, or I can simply call it current and I have to do while current.next is not equal to null and k should be greater than 1 to move my current equal to current.next and decrement my k, and at the end my current would be my kth node. That is the end of that part. So after I find my end one, I need to set end1.next. So I can set my right equal to end1.next because this would be the starting of the next part. So now I can set end1.next equal to null. So what could happen is end1.next can be null itself. So that would lead us to assign the value of right as null. So we need to check if right is not equal to null. Only when right is not equal to null, we find the end of second part. So we find kth node, right and k, and need to set my next variable now. So I need to define it here first, next equal to null, and then I can set my next equal to end2.next and break the linked list here. And after I have this, I can merge. So can find list node merged equal to merge to sorted lists. I can pass in left and right. And now this is going to give me the merged subproblems. And then I can assign my previous dot next equal to merged. So we are reconnecting the merged subproblems to our original linked list. So here we set previous dot next equal to merged, and now I have to find the end of the this merged part. So need to do previous dot next is not equal to null. So previous equal to previous dot next, and then I can do previous dot next is equal to, this would be equal to my next, because that would be the beginning of the next pair. And then I can set my current equal to next. Perfect. Yeah. And once we are done with this, so I have my current here. So when I move on to next pair, I am going to start from here, current equal to next, and I already have my previous assigned. So when I'm going to reconnect it again, then it would lead to right connections. So let's try to run it and see if we have any errors. So that's good. It worked in our first attempt. We can make this code a bit cleaner by redesigning our find kth node function. So here, instead of finding the kth node, we can call it split. And this function, instead of returning the end of a part, it returns the next node of a part and sets end.next equal to null before returning the next node. So what it means here is, instead of checking current.next is not equal to null, I'm going to check current is not equal to null. And after the while loop, if current becomes equal to null, then we simply return null. And if current is not null, then what we are going to do is we are going to save it in next. So current.next, and at the end we have to return the next node. And before returning the next node, we can set current.next equal to null. So here what it does is it breaks the linked list and it returns the next node as well. So it does two steps in a single function. So here, instead of returning end1, so we can remove it from here. So My function call, it's going to give me right node straight away. So here I'm going to call split, and then if I do left and k, so this is going to give me the beginning of my second part, and it's also going to set end1.next equal to null. So we can simply refactor it in a separate function. And then after I get my right, I can remove this. Don't need to worry about it. So I can remove this. And if I call my split function on right and k, what it's going to return is going to return me the node for my next iteration. So it's going to give me current. So I don't need to set my current here, and I also don't need to set my previous dot next here. And now let's try to run it, and that works, which is good. So we simply refactored it, and as you can see, it's much simpler when we just simply returned the next node and also modified our linked list. So I hope this made sense, and if you have any doubts, let me know in the comments, and I'll see you in the next video. Thank you for watching.